Hello everyone and welcome to this video. So in this video we'll be looking at hyperparameter optimization using a library called Hyperopt, and then we will log whatever metrics and whatever artifacts are generated during this hyperparameter optimization in MLflow. So previously we developed some models. We developed logistic regression, XGBoost, and a Keras model. So I have copied some parts of the logistic regression model, so importing the packages and reading our data and the data pre-processing. I've copied those parts of the model. I've also imported some libraries, so you can see from Hyperopt. Hyperopt is the library we'll be using for hyperparameter optimization, and we will also be doing cross validation, so I've also imported that library. So we have from Hyperopt import TP. TP is some type of optimization algorithm. You can read more on that if you want. And so let's go ahead and then run this cell. I'm going to run this cell too and do my data pre-processing, set up experiments, right? So the first thing actually is not to set up my experiment, but I'm going to define some objective function, right? Because you need objective functions whenever you are doing some hyperparameter optimization, right? So I'm going to specify the number of crossfolds. I'm just going to use 4 max evals. I'm going to specify to 10, and then I'm going to specify my optimization on my objective, right? So let me just put another here. So this will be define objective function, right? So we define the objective function, and this will be def objective, right? So we have some params, and then we have some n folds, which is my n folds, right? And then we are going to define what is in this objective function, right? So I'm going to say MLflow dot sklearn dot autolog. So whenever this function is running or whenever it's optimized, I just want to automatically log the metrics and artifacts and whatever is being generated, right? Now I'm going to start so with MLflow dot start run. Now I'm going to specify a parameter here that you would understand why this is needed to be specified later. So this parameter is nested is equal to true. You understand later on why we need this parameter. And then I'm going to create an object of the logistic regression class, and then just explore the parameters here, and then random state should be 0, and then let's see what scores we have. So cross val score CLF x train y train CV is n folds. So what is our scoring? I want to use F1, so F1 macro and then our best score will be, I'll just use the maximum of my scores, right? So this is, we want to maximize the F1 score, right? However, Hyperopt requires a function, a minimization function, right? So if we just leave this, we are just going to get the minimum of the F1. Yeah, it's not, you're not going to get the optimum value. So we have to use the inverse of the best score, right? So I'll say my loss is 1 minus the best score. So we want to minimize this, right? And then I want to return something. I want to return my loss. I want to return some param, which are my parameters, and then this flag status, right? Right. So this is what we have for our objective function. Now, after defining your objective function, now you need to define the space of your parameter, right? So define your parameter space, right? So here, if you do not know the parameters that go into logistic regression, you can just look at the documentation for sklearn, so sklearn's logistic regression, and then see what kind of parameters you have and what options you can put or you can specify for those parameters. So here we are going to list some of the parameters and then what options you can specify for those parameters. So the first one is warm start, right? It's a parameter that you can specify in logistic regression. So for warm start, so I'm going to say hp.choice. So this is how you can, so hp.choice, so choice is you can a whole lot of choices, right? So you it's just going to select one of those choices that you list and then use that parameter and then see if it's optimal or not. So hp.choice, you have to name your choice, so warm start, and then you specify what choices. So for warm start, from the sklearn documentation, warm start can either be true or false, right? The next one is fit intercept, right? So I'm specifying, so all this is as a dictionary, right? hp.choice, so you name it fit intercept, and it can either also be true or false, right? The next parameter is a tolerance, right? So for the tolerance, we will not use hp.choice. Instead, we will use another one called hp.uniform. So hp.uniform, so as you guess, it's just going to return a value, a uniform value between these two bounds, right? So 0 point and then 0 0.1231. The C hp dot uniform, right? And then 0.005. I'm just going to do 0.05 and then 3. Right. And then we have the solver here, hp.choice. And then we have to name that solver. So then we put in a list of solvers, right? So some of the solvers that you have for logistic regression from the sklearn library. So yeah, you can go ahead and then read on all these solvers in the library later on if you're interested in doing that, right? And then you also have, let's do a last one, max iter. So that would be hp.choice max iter, and here we will specify a range of values, right? So from 5 to 1000, right? So this is our space. This is the space that we want to use for our hyperparameter optimization. So the next thing we will do now is we will create the experiment. So create experiment, right? So create the experiment, and then we'll say MLflow dot set experiment, and then we will name it Hyperopt optimization. Right. So so when we go to the library, we refresh that, we see we have a Hyperopt optimization experiment created. So just a side note, so you see how as we are going through MLflow for experiment tracking, you can see how useful it is. In a production environment, you would set this MLflow experiment or model registry somewhere in the cloud where all the data scientists in the company would have access to, and then you can all run your experiments. It's all going, your metrics and your artifacts are all going to one place in one dashboard where anyone who is on the data science team or the machine learning team can see what experiments each data scientist or each machine learning engineer is working on, and you can also compare which metric is whose model is currently the best and something like that. So it helps you to work also in teams, not only helping you to log your own metrics, but if you're working in a team and you're using one MLflow repo, you can, or registry, you can see what each other is working on. And I think in a later video I would probably show you how to set up MLflow like in a real production environment on GCP, and yeah, and I think that would be fun to do. So but for now I'm just showing you how to use this in your own personal projects. So let's go ahead, and so we have created our experiment, so let's go ahead and then use it. So I'm gonna say define optimization trials, right? So first I'm gonna say algorithm. So what algorithm are we going to use? So we say TP algorithm, It's just, I'm just going to say tp dot suggest. It's just a simple random search, right? And then I'll say base trials. This is just trials, right? Now, to start an MLflow run, we all know that we have to say with MLflow start. So we say with MLflow.start run, and then we have a run name, Hyperopt logistic as run. Now the reason why we put nested is equal to true here is because this MLflow run will be nested in this MLflow run, right? So that's why we specified nested is equal to true. We are going to put this objective function in this MLflow run, so we had to specify that this MLflow run is nested in another MLflow run, right? So we'll say our best, right? So what are we minimizing? So we are minimizing some objective, so we say fmin, right? What is our function? This is the objective that we specified previously. Our space is the space that we specified previously. Our algorithm is the TP algorithm that we have specified already. Our max evals is our max evals that we specified. Our trials is our base trials, right? So then when you run this, we will get some best parameter, right? So after getting the best parameter, I'm just going to put that best parameter in the dictionary. So I'll say k float of v for k and v in best dot items, and then I'll say MLflow dot log dict best. I'm gonna log this, so best params dot JSON. So I'm gonna log this in a JSON, and then let's run this. Hopefully we don't get any errors. If we get any errors, we just solve them. So as you can see, it's running. It's on 20% now. Let's see what will happen when it's done. All right, so it's done. So let's go back. Let's go back into the MLflow UI and refresh that. And then you can see all our hyperparameter optimizations. So for all of the runs, you can see the F1 score, and you can see the F1 score for all of the folds also, right? So because I specified fold is equal to 4, so it will split the data into 4 parts. 3 for training, 1 for testing. So that's why you have that. Alright, so let's open this and see. So you have some graphs, and you can look at this later. And then when you go back and then you click on you see your best parameters here. So you have the C fit intercept 0, max ITA is 264, your tolerance, warm start So this will be the parameters that you can choose to train your best model, right? And yeah, that is all for hyperparameter optimization. So your challenge is to go look at the Keras model and try and then do hyperparameter optimization on the Keras model and then the XGBoost model using this little information that you have seen in this video. So this is the end of this video, and I hope you have learned a lot. So this is just for experiment tracking in MLflow. So in the earlier videos I told you MLflow has three main components: MLflow tracking, which we have looked at; MLflow projects, which I don't really use much, and so I might not talk about it, but if you're interested you can see the documentation on what MLflow projects are; and MLflow models, which are really great to use. MLflow models helps you to so as you've seen from the experiments that we run, so you can see that the XGBoost model looks something like this, right? If you want to use it, yeah, you just say MLflow the python.load model, and then you load this logged model, and then you can just do the prediction, right? So you can see the how to use it, how to use the logged MLflow model is just as simple as this. So this is for a Keras model. If you go to XGBoost model, so you can see it's the same way to load an XGBoost model and then a Keras model. So you just have one structure or one way of loading your models. You don't really care if it's an sklearn models or it's a TensorFlow model or it's a PyTorch model. You just have just one simple way of loading and then using the model. So that makes MLflow models really great. We would also come to how to use MLflow model registry, and I would like to talk about this when we get to the real production environment. For now, I will just end this playlist here on this video. In the later videos, I would show you how to set up the MLflow infrastructure on Google Cloud Platform and how you can run machine learning pipelines using this platform. So for now, this is just a brief introduction to MLflow. I hope you've learned a lot, and don't be afraid. Go into the documentation and explore more. And I hope to see you in my next videos.